Hello everyone. So today we are going to look at another problem which is called left rotate array by d elements. So in the previous video we learned about like how to left rotate an array by one place, where what we did, we just had a we just simply shifted every element to the left by one place, and we stored our first element into a temporary variable, and just after running the loop we just stored this element at the end of the array. Right. So what we are going to do here is, what the question asks is, we have to rotate the array by d elements. Here d is 2, that means we have to rotate the array by we have to rotate array by 2 times. Okay, we have to rotate array by 2 times. So suppose if we have to rotate the array one time, what would be the output? 2, 3, 4, 5, and 1. And we have to rotate array one more time. So it would be like 3, 4, 5, 1, and 2. Alright. So every element is shifted by twice. Every element is shifted twice. 4 in the end has come here, 3 has come here, 5 has come here, 1 has come here, and 2 has come here. Alright, so this is what we have to do. Now take 2 minutes again and think of a solution like how you can deduce this. Right. So let's first of all let's talk about a very nice solution. So this is a nice solution. So similarly, like left rotate an array by 1, we are simply doing the same thing. What we are going to do here is, we are having a temporary array of d size. Alright. And what we are going to do here is, we are going to store first d elements inside this temporary variable. Okay. And then simply we are going to shift every element by d places, and after that we are going to have the temporary variable in our array, similarly like what we did in the previous question, left rotate an array by 1. So let's have a dry run here so you can understand it better. So what we have here is 1 2 3 4 5. All right, and inside our temp we have 1 comma 2. Now what we have here is, we have I is equal to d, I less than n, I plus plus. That means we have to solve our array from 2, yani from here, right? Now what it states that array I minus g is equal to array I. So array I minus d here is 2 minus 2 0, right? So that means this element would be replaced by array I, which is this element. So that means 3 comma 2 comma 3 comma 4 comma 5. Now a pointer would be here. Now array I minus g. Now array Ri is 3, 3 minus 2 1. That means this element would be replaced by 4. So it is 3 comma 4 comma 3 comma 4 comma 5. Now our I is here, which is 0 1 2 4. I is 4, D is 2. So second element, second index is this. This would replace by 5. So it would be somewhat 3, 4, 5, 4, 5. So we can see that after this operation, only a last D elements, which here is 2, needs to be adjusted. Otherwise, this part is according to our solution. All right. Now, what we can do here is we just have to simply put these elements here. All right. So what we do here is we replace array of n minus d plus 1 by temp I. Now you must be wondering why we are doing this, because okay, suppose n is what, 5 here, right? And what is d? 5 minus d. D is what, 2. 5 minus 2 is 3, plus, okay, this is not 1, this is I. All right, 5 minus 2 plus 0, that is 3. So R3, which is this element, is going to be replaced by temporary 0, which is this one. So it turns out to be 3, 4, 5, 1, 5. All right. Now our I becomes 1. Now what will happen? N will is 5, D is 2, but our I now becomes 1. So this overall becomes 4. That means this element would be replaced by our temp I, which is this, right? So our final array would look something like this. All right, our final array would look something like this, right? So this is our final value. Now, what would be the time complexity of this question? The time complexity of this question is going to be big O of n. And what would be the space complexity? It is going to be big O of, or theta of d. Right. Because see, we are always going to have a temporary variable of d size. Now come up with a solution which takes big O of n time and theta of 1 linear space. Okay. Now I hope you have given a try to that question, and I know that the solution which I'm going to tell you is a very observational algorithm. Like, it is not an algorithm, it is just an observation. All right, and I'm pretty sure you might not have found it, and it is all right because this is just an observation. So what we do in this algorithm is, since we have to uh, left rotate an array by d, what we are going to do here is we are going to reverse array from 0 to d, which means we have to rotate this part, reverse this part. Then we have to reverse the part from d till n minus 1, which is this part. And then we have to reverse the whole thing. So first we have to reverse this thing, that is 2 comma 1. Then we are going to reverse this thing, which is 5, 4, 3. Cool. Now what we are going to do is we are going to reverse this whole thing. So the whole thing would be 3, 4, 5, 1 and 2, right? So see, reversing this thing, rotating this thing, there's no serious connection, basic connection here, right? A concrete connection is not here, but we are still doing it because we have observed this thing, that if we reverse this, part, and if we reverse this part, and if we reverse the whole thing, we'll get this thing. All right. So I am again saying it is all right if you could not find this solution. But now, since you have seen like you can do this thing also, you must keep this algorithm is also in your mind, that if you have to rotate a thing by d places, if you have to right rotate a thing by d places, you can like reverse the thing and reverse the whole thing. All right. So this algorithm now you must have, like, you can do it in the further questions. This can also be an approach to further questions. All right. So what did I say here is, again I'm telling you, for elements 0 to d minus 1, reverse them. Then from elements for d to n minus 1, reverse them, and then reverse the whole array. All right. So this was all you have to do here. So the time complexity here is what? Theta of 1. But auxiliary, but time complexity here is theta of n, right? And space complexity is theta of 1, right? Now let's try and code the solution. Let's have our header file, our using namespace. Let's have our int main, where we'll have int ar as right, n as 5, comma d as 2. Again, cout before rotation. All right. Write it as for int I is equal to 0, I less than n, I plus plus. Cout I. Cool. Okay. I did some mistake here. All right. Now it's good. Yes. Okay. And this. Okay. Why is this error coming here? And I um let's see why this error is coming. Let's have the terminal open. See this problem. Okay. Let's write this again. All right. I guess I didn't put the array thing here, right? Now I guess, yeah, now it is. So, cool. Now what we are going to do is derotate. We'll name a function derotate. We'll have int arr, int n, and we'll have int d. All right, and let's have cout endl here. Now we'll write cout after rotation. We are going to again run our loop from I0, I plus, and we are again going to simply cout our arr I. All right, so this was the basic int main function. Now let's write our void d rotate int arr, int n, int t. All right, now we have to solve this thing. So what did I tell you? We have to first reverse. We have to first, reverse our array from 0 to d minus 1. Then we have to reverse our array from d till n minus 1, and then we'll just simply reverse our array from 0 to n minus 1, right? Now what we are going to do here is we are going to have a function void reverse. We are going to have int arr, we are going to have int low. This is a reverse function which I already told you, but since this question needs it, we are going to make a reverse function. Right. What we are going to do here is we are just going to simply swap arr low with arr high, and we are going to do low plus plus and high minus minus. Right. What is the why is this error coming here? And okay, 1 minute. Yeah. Now there should be no error. Let's see. All right. Yeah. Okay. Or I have already told there's a swap function present already here. Okay. Yeah. There is also reverse function. Right. Okay. What we're going to do is we are going to name it reverse. Right. And we are going to name it reverse. Cool. All right. This is not correct. I did few basic errors here. So these things also happen sometimes, right? These things might happen with you also, but okay, bear with me. So yeah, now the code is correct, right? So let me tell you again what we did here is we have our main function. All right, we have now our derotate function. So what we do here is we reverse it from 0 to d minus 1. Right, let's do it here. What we are going to do is we are going to reverse this part, right? Then we are going to reverse d to n minus 1, meaning from here to here, and then this we'll achieve this thing. And then what we are going to do here is we are just going to simply reverse the whole array. Yeah, which means we are going to simply reverse the whole array, which means 3, 4, 5, and 2. All right, and we have written the reverse function where you can write a swap function on your own, or if you have included the bit header file, the swap function comes along with it. So let's save this thing and try to run it. It was not declared in the scope. Okay. Oh, all right. We have to, have it here. Right. Now let's try and run it. All right. Give me 2 minutes. Let's now run it so you can have a better view. See, before rotation it is 1, 2, 3, 4, 5, and after rotation it is 3, 4, 5, and 2. 3, 4, 5, and 2. Yeah, that is the correct output. Right. So yeah, that's it. So that was the whole code. Right. So here also we discussed two approaches how to solve this. The first approach was, taking theta n space, theta d space, and another approach was taking theta 1 space. So the efficient approach was the second one. The second one had some observational algorithm where we observed from the example, like how we can do this thing, and then we did it. All right. So I am like, it is fine if you couldn't find the efficient approach, because but now you know that there is an observational algorithm also, which you can um, apply now in the in further questions in the series. And yeah, that's it for this video, and I hope you got the key concepts from it. And yeah, that's it for this video, and see you next time.